Hello everyone, welcome back. So in this video, we are going to understand another questions for the contest 163 is number of perfect pairs. The question is saying that you are given an integer array nums we have given and a pair of indices I and j we have given. We can call it a perfect if the following conditions are satisfied. What are the conditions are there? Let me zoom a little bit. Okay, so the I should be less than j, sorry, and it should be a should be equal to num set I, okay, and b should be num set j. Then these conditions should satisfy, means mean of absolute a minus b, similarly a plus b, and similarly we have to take these values, okay. In less than equal to, if we are taking the max, it should be greater than equal to, right? Like these two conditions, it should be match. Then we have to return the number of distinct perfect pairs, okay. And what is this? It is saying in the note. Now understand example. So example 1 we have given, nums we have given, output is 2. So it is saying there is two perfect pairs when I is 1 2 and I is 2 3. Then we are getting the value is 2 and 3 here, and in mean we are getting 1 and 2, okay. That is why it is saying it is a perfect pair, okay. That's all we have given in this example. So what the question is saying that, let me explain you, okay. So very first, we want the pair, right? Let's suppose pair is what? Let's suppose if we have two elements, we have a and b. So this is called pair. So if we want the pair a and b, it means what? Condition was saying mean a minus b and of a plus b. And if it is like this, it is saying mean of a minus b, right? Comma mean of a plus b. If it is less than equal to mean of this value, right, this value, if it is less than equal to this, means less than mean of a mod and b mod, we can say that, okay. If it is less than equal to, similarly if it is max, here we will do the same thing, only will max here, but it should be greater than equal to. Understand? Let's check what happens if we just look at the absolute value, okay. So let's say we'll call it a, and if a is just a, right, and b is nothing but absolute of b, so can we assume that a is less than equal to b, just for clarity, right? So then we can say a minus b and a plus b is what? Both depends on a and b. But when we take the minus, let's call these things, right, a minus b comma a plus b, can we say that when we are calling a minus b and b minus this one, can we say that this is nothing but what? A minus b. Can we say that? We can say that. This is a key trick to understand this problem, okay. Whenever you writing mean a minus b comma a plus b, right, it is nothing but what? Absolute of a minus b, just that we have suppose, right, we can say that, and it is a nothing but your key trick to understand, okay. So the condition becomes what? Let me clean, or you can say, just let me write here. You can say a minus b is less than equal to a. Can we say that in the case of when we are writing mean of a minus b? So this second condition, when we talk about the max, is always satisfied once this condition holds, right? Let's simplify that. Let's understand, if we have a is less than equal to b, right, can we say a minus b that we have seen is nothing but b minus a? So we can say condition is nothing but what? B minus a is less than equal to a. So we can say b is less than equal to a. So this is nothing but what? So the perfect pair rule is just we can say right here is smaller absolute is less than equal to what? Larger absolute. If it is really, it means what? Is nothing but 2 into a smaller. absolute. Either you say this one or you say this one, right? If B is less than equal to 2A, what does it mean? It means smaller absolute is less than equal to larger absolute, right? And is less than equal to what? 2 into a smaller absolute, right? Let's understand how. Very first, we have some absolute value we can take, okay? For this case, let's talk about this one, okay? Or let's take out 2, 3, 4, okay? And just take some indexes. Index is, let's suppose this is I, this is your J, this is your K, and this is your L, right? So for each number, let's suppose we call for 1. When we call for 1, what are the valid partners must be between 1 and 2? So the pair is 1, 2. Can we say that? When we are talking about for 2, so the valid partner is nothing but what? Between 2 and 4. We can say that. And so here, the 2 pair will be there, 2, 3 and 2, 4. When we talk about pair for 3, right? So the valid partners between 3 and we have to take this time about 6. Can we say that? Here pair will be what? 3, 4. Right? Correct? When we talk about the 3, the valid partners must be between what? 3 into 6. Right? Just we have seen the formula, right? B is less than equal to 2A. Right? It should be in the distance. So it will become what? The only pair is 3, 4. But when we talk about the 4, right? We do not have higher partner in this range, right? Because if you talk about the 4, we have to go to till the 8, which is not in our here in the range. We don't have. It means to get the pairs, what are the things, what are the pairs we have? 1, 2, 2, 3, 2, 4 and 3, 4. These are the pairs we have in this range. I hope you understand, right? So we don't need the brute force, right? We just do the sorted absolute array, right? And then we'll get it. How we are get it? When we'll talk about I is equal to 0, right? Value is 1. We'll move till what? Until 2 into 1 should be less than 2, right? So the cover we have to cover is 1, 2. So like that we have to cover. Let me show you how to implement it, okay? Otherwise I will create another deep dive session because still we have 44 minutes, so you can solve this problem. So I'm saying, so if your judge insists on int, right, cast at the end, but beware of the overflow, right? So just you have to focus on getting the value, right? So this is your nums we have given, right? And what you need to do, we have to do int n is equal to nums dot length. You will get the n, means we have to find the to not in the overflow, we will take the int long, right? And what we need to do here, just think, we'll take from 0 to n, and AFI, you know, nothing but the absolute value. All the absolute value will fill here very first. Then we'll do the sort. Why we'll do the sort? If we'll not do the sort, how we'll do the sliding or sliding on the 2 pointers algorithm? How we'll apply and do the sliding window? We need 2 pointer to the sliding. We'll start from J, and this is your I, like a left right you can take, okay? So this is, let's suppose this is your left and this is your right side, okay? Or this is your, we have to slide the writer point like that, okay? So start from I, right, and go to the n, right? If j is less than I plus 1, just increase j from I plus 1. But you have to check this one also. If j is greater than equal to greater than I, j is greater than I. So this condition we have to also check. That is why we'll check j should be less than I plus 1. Otherwise you keep updating it, okay? While condition will make and we'll keep growing the window. So here we have to take, if array at j is less than equal to 2l, 2 into a, you have seen, right? If the b absolute means b is less than equal to 2a, right? Then we'll do what? J plus plus, and we'll do the count. How we'll do the count? count equal to plus equal to I minus j minus I minus 1, and we'll find the absolute pair and we'll return the count. Okay, what I'll do, I'll create another deep dive video, right? And I will try to visualize you so you can understand here. So for now in the contest, I'll just put this video so you can do the solution, right? Okay, but let me know in the comment section you want the deep dive or not, and if you are good to go, just write the comment section, we are good to go. Okay, thank you guys, thank you for watching this video. I'll see you in the next one.